Welcome to the lesson on simplifying algebraic fractions. We're going to talk about a few illegal cancellings first. So sorry I'm rushing through this really fast, so sorry if there's mistakes. I'll try to, if there are any mistakes, I'll have to fix them up later for you. But I want to make sure this is ready for the next lesson. So what you're asked to do is beware of the following. So every time you do this, so just kind of cancelling down here, where they go cancel that and that. Every time you do this, the kitten dies. So what we want to discuss is why. Why can we not just cancel down a term and a term? And one thing, when you're cancelling algebraic fractions, as we've mentioned down here, like down here, when cancelling algebraic fractions, only factors can be cancelled, not terms. So are there any common factors to the numerator and the denominator? So are there any factors of the numerator that are also factors of the entire denominator? So you could try to factorize, for example, x squared plus 2x plus 1. So that would give you x plus 1, x plus 1. Let's try it out. So this is how you can test it out. So x squared plus 2x plus 1 can be simplified to x plus 1, x plus 1. Remember, practice your factorizing. What two numbers multiply to give 1 and add to give 2? X plus 1, x plus 1 over x squared plus 3. X squared plus 3 doesn't factorize. Are there any common factors? No, there's not. There's x plus 1 in the top, but there's not an x plus 1 in the bottom. So we can't actually simplify this. So no common factors. So specifically the word factors, we're not talking about common terms. There should, to be able to simplify, there need to be common factors in the numerator and denominator. No common factors in the numerator and denominator. So they might have seen the meme above before, and that's why they say a kitten dies every time you try to cancel down a term as opposed to cancel down a factor in an algebraic fraction. So let's go on to the next one. Again, I'm going to try to rip through these for you so we can get through the notes quickly. So every time you do this, x squared plus 9 over 3x squared minus 27. So notice what they did, they factorized this. So a common factor, that factorizes to 3 brackets, x squared minus 9, because you can take out 3 as a common factor from the denominator. But when you do that, what did they do here? They made an error. That's right, that should be x squared plus 9. Sorry, no, what am I saying? That is x squared minus 9. But notice at the top is x squared plus 9. So some think that if you do x squared plus 9 divided by x squared minus 9, for some reason it equals negative 1. That's not the case. So why? I'll just write that up again. So the fraction, as you can see, it factorized it. X squared plus 9 over 3 x squared minus 9. And either way, yeah, so x squared plus 9 is a different x squared, well, basically they said x squared plus 9 divided by x squared minus 9 equals negative 1. But it does not equal negative 1. So that's a common misconception, apparently. Again, I'm just ripping through this pretty quickly. So every time you do this one, chipmunk dies. So let's see, what did they do here? This looks like a result from solving using the quadratic formula or completing the square, doesn't it? And I remember a lot of people tried to do this illegal cancelling down here. So this is why I thought I'll pop this one in, because to some extent it is sort of like a fraction. It's a result of solving using the quadratic formula. So notice that what the error was that this person cancelled down only a 2 and a 2, but you needed to factorize the entire denominator, the entire numerator first. So if you can actually simplify this, but you need to divide 2 out from here, here, and here in order to do that. So let's try that out and see what the answer should be. So the question was x equals, plus the answer so far was x equals negative 4 plus or minus 2 root 3 over 2. So we need to be cancelled out 2 from all 3 terms, and I'll show you why. It's because you need to take out 2 as a common factor. So there would become 2 brackets negative 2 plus or minus square root of 3 all over 2. And then upon doing that, then you can cancel down the factors. So we don't cancel down terms, so we don't do that. Let's do that because that's wrong. We cancel down factors. So back to that before, we cancel down factors, not terms. So that's an important aspect. That's what it should be. And then therefore the final answer, this one by the way, would be equals negative 2 plus or minus root 3. And this is the correct simplified answer. Okay, on to the next one. So every time we do this, a hedgehog cries inside. Slightly off topic, but it's still to do with fractions. So just another thing that pops up. Square root of 2 over 2 does not cancel down to give you the square root. Square root of 2 is an entirely different number to the number 2. So you would just leave this one, should remain as the square root of 2. So square root of 2 is a completely different number to 2. So it should be left as just square root over 2 over 2. That's what it should be left as. Okay, one more I think. So every time you do this, Grumpy Cat smiles. So let's see what error has happened here. So the error seems to be more so in the cancelling down. So what did they do? So the error was they cancelled down terms and not factors. So they cancelled down terms. For example, they cancelled down x and x squared, and then they cancelled down 3 and 9. So they cancelled down terms, not factors. So if you were to attempt to simplify such a problem, we'll show you how it should look instead. So let's write the problem out again. So the problem was x squared minus 9 over x plus 3. So you might find the answer could potentially be the same, but the error is in the working out, like the cancelling down with the red and the cancelling down with the blue is not correct. So if you were to factorise the top, notice that the top is r. Try to think back to Unit 1. What kind of quadratic equation is on the top, or quadratic expression? That's right, it's a difference of squares. X squared minus 9. And when you factorise a difference of squares, remember you write x plus 3, x minus 3. So like x squared minus 2 minus 4 would be x plus 2, x minus 2. X squared minus 1 would be x plus 1, x minus 1. And so on. So you would have to factorise a quadratic on the top, and then you've still got x plus 3 on the bottom. So what can we cancel down? We can cancel down x plus 3, and so the answer is actually x minus 3, but for different reasons. So the answer is still x minus 3. The error was in the method. The method. And the error in the method was they needed to factorize first. So they needed to factorize first and then cancel down factors. So simplify by cancelling any factors which appear in both the numerator and denominator. I actually do have one on the next page before we go into the examples. Okay. That's right, every time you cross cancel, this is more related to a later topic, but I thought I'd pop it in here while I'm topic. Every time you cross cancel, group really hopes you're kidding. So notice we've got 7 over 5 equals x over 7. So remember, when you see a problem like this and potentially you're asked to solve, you shouldn't do any of this cross-cancelling business, because notice that they're not multiplied. There's no multiplication sign here. And I think the person is mistaking it for 7/5 times x over 7. And then in which case you can kind of do a little bit of cancelling down like this. When you have an equal sign, what you need to do is you need to cross-multiply instead. So if you're asked to solve this, you should cross-multiply instead. They've mistaken the equal sign for a multiply when you can kind of cancel down. You should cross-multiply and solve instead. So later on, one of the last topics is about solving. So instead they had, so what did they have? 7 over 5 equals x over 7. So later on you're going to be asked to solve such things. Remember, you would cross-multiply. Just point it out and do that times that, and that times that. So the yellow one, x times 5 is 5x, equals the red one, 7 times 7 is 49. And then you would just solve that. So x equals 49 over 5, which doesn't simplify. Brilliant. Now let's try a few examples where we need to cancel down and make sure we're doing correct cancelling, not illegal cancelling. So what we've got to think about is what are some common factors before we do any cancelling down. So 3a squared and 9a squared. What you could do is you could potentially kind of expand it. Some people like to sort of factorise it a bit first, but if it helps, you can also expand it. So that would be the same as 3a squared. Try to think back to index laws. 3a squared times 3a squared. And if you're finding it difficult, just do 3a squared times 3a squared. If that helps. Over 9a squared. That might help you out a bit. And then that would give you 9a to the power of 4 over 9a squared. Because remember, you add the exponents and keep the same base. Or alternatively, you would have to square the 3 and multiply the exponents if you're looking at the top bracket version. So 9a to the power of 4 over 9a squared. What cancels down? We can cancel down. The common factors are 9. And we can also cancel down a4 over a2. Remember a4 over a2? If you want, I'll do it in steps for you. a4 over a2. Remember, when you're dividing exponents with the same base, you subtract the exponents and keep the same base. So that would give you a squared. So the next one's interesting. We've got 4m plus 8m over 2m. So the common error, don't just follow this, this is an error. Common error would be just to do that. But remember, that's when you kill a kitten. Because what you need to do is try to think what's a factor that's common to all of the top and all of the bottom. So let's see. So perhaps it's just a number. So if it's just a number, what you can do is you can take out 2. You can factorise this by doing taking out 4 from the top. So 4m plus 2n over 2m. And now see, are there any common factors? So the only common factor is 4 over 2, cancels down to give you 2m plus 2n, which is the same as 2m plus 4n. So you had to say that to be able to cancel down a letter, you have to have a letter in all 3. So unfortunately, that's not there. Okay, so moving right along. Next one. We have x plus 2 squared. So you might want to write that out as x plus 2, and x minus 1 squared. So maybe I'll do that in red. It's all just multiplied, so keep them next to each other. That might help. Do that. All over x minus 1 squared. Which is going to be, actually, I'll do that in red, just to point out it's the same. One above. X minus 1, x minus 1, so you can expand that. Multiplied by x squared. to cancel down. We can only really cancel down this one and this one. In a way, I could have just. And the reason we wrote that.
That's square rooted? Just like,
Oh,
like that?
You could not solve it, we could, but we could.
What?
This is a video, by the way.
I wonder why you were talking to yourself. I'm sorry.
That's okay, we'll keep going. And to be honest, I don't need my voice anyway, so I might actually take the voice out.
I'm so sorry.
That's okay. Okay, so then what we can do is we can rewrite this as. So x plus, we can write it as x plus 2 all over x squared. So x plus 2 over x squared. You can expand this, you would get x plus 2 x squared. So x plus 2 x squared is x squared. Doesn't have x plus 2. Or does it? Let's see. And then we can write this in slightly more simple as well. You could also write x plus 2 squared over x squared. So we'll just leave it as and then the next one we've got x y plus x squared over y. So we need to factor we can factorize which would leave us with y plus c. And if it helps, x bracket y plus y plus b. So just be aware of y minus is different. So if you want to count down your factors, so this is a nice one. Straight to let's move on to the next example.
Like you,
Okay, so we can take out.
Wait for it. You need to repeat. You don't need to repeat.
Top line 3x minus 3 and it's just a linear expression. That leaves us with y. Try to think that if you took out negative x from the denominator instead, you would actually have a common factor then. You would still have 3x minus 1, but if you had taken out negative x, then that would leave you with negative 1, which means you could say that 3x minus 1, negative x, you write negative 1 from that's an interesting property. And then we actually get a negative, and suddenly have so be wary of particularly in exercise now on our last two. Top. And the bottom quadratic.
Yeah, thanks.
And then we've got x squared
I was going to change there. I have half an hour. Get there a half hour early. I really bring my lunch box.
multiply the view with negative 40 and add the view.
Oh my God. Are you going right now?
What about so negative 3 will have 3x into negative 8x.
Okay, awkward.
And 5 plus 5.
Oh, I have to schedule my bag.
Well, where are you going?
Yeah.
I said I was going away. I didn't say where I was going.
So now we can
Never mind. Today, the next at 1:15.
minus 8x plus 5x plus 8 minus 8x. 3x into minus 8x plus 5x. And then 5x we can take So